Alright, I'm back with another project of sorts. I wasn't gonna film this, but this isn't it, by the way. But I got a hold of a Harman Kardon transistor amplifier. It's perhaps one of the last ones they ever made. I think Harman Kardon still exists, but not really in their original form. And I think they make receivers. But they don't really they don't do amplifiers anymore. Of course, Harman Kardon was once, you know, one of the great amplifier companies. But I think all the Harman International, I don't know what they've done with the brand. I think they still make pretty decent receivers, but they're not really considered high-end. They're just sort of kind of good quality, top-grade consumer equipment. But I don't even know anyone that sells them. We have Best Buys around here. We have a Crutchfield, but I don't know anyone that sells Harman Kardon. If I wanted to buy a, by the way, I gotta replace. These are my 8-ohm dummy loads, and I have had these very thin. I don't even know what gauge this is. 20 gauge something speaker wire on here for the longest time, and I need to get around to putting some fatter speaker wire on there. But anyway, so I have this amplifier. It's I'm going to show you in a minute. Pick up the video camera and go over there and look at it. It's a Harman Kardon PA2000. PA2000, and it's a 4-channel amp, but it's a stereo amplifier. So you put in your left and right signals, and you get 2 discrete left channel outputs and 2 discrete right channel outputs. Good for bi-amping. You know, if you want to bi-amplifiers, speakers. And it's one of their old, what they called high current designs, ultra wide bandwidth, low distortion, good stuff. And I bought the amp a long time ago, and ended up giving it to my brother-in-law to complete a system that he had, a system surrounding some NHT 2.5i speakers, which were just fantastic. I had a pair a long time ago too. Just really good stuff. And I had just purchased a Linn Linn system, L-I-N-N, Linn from Scotland. And it's probably the most expensive system I ever had. This is probably back in the year 2000, shortly after that. And so I gave him this Harman Kardon amp that I was using prior to the Linn system, and he used it for many years, and then he had a flood in his basement where his stereo was, and some water main pipe broke upstairs and flooded the basement, and water was just coming through the drywall and the light sockets, and it fell into his TV and into his stereo. And so he was concerned that this amplifier took on water, and it probably hasn't been used for about 3 to 4 years now. Even before that, he said he wasn't using it much. So one thing that electrolytic capacitors don't like is to not be used. They want to be used. Something happens to them where the electrolyte leaks, or they dry up, and they want to have a voltage applied to them. And so I'm concerned that maybe the capacitors need to be replaced, or I'm concerned that water infiltrated the whole thing, and so I need to check that out, and then I want to get it running again. So he gave it back to me, and I might want to use it for my drum set system, because I'm using a crummy receiver right now that's clipping. So here it is, PA2000, and show you the back of it. It's got some neat features. I don't use all these features, but it's got separate left and right gain controls. It's got music sense, which is automatically turns itself on when it sends a signal and goes into a standby mode when there's after so many minutes after signal is not applied. It's bridgeable. You can bridge left and right channels to get more power. And like I say, it's like 4 discrete channels. And the specs are 45 watts for each channel, 4 times 45 watts for each channel. If you bridge them, you have 200 watt, 2 100 watt channels. And of course, Harman Kardon's, they've always touted their high current capacity, in this case plus or minus 45 amps, and that is almost, high current is almost more important than power, maximum power output, because speakers, a lot of speakers are complex loads. They're not just like an 8 ohm resistor, and if they get really complex in the near the bass frequencies, when that's where all the power is really, then you could have instantaneous current draws that could clip an ordinary amp. So Harman Kardon is always, for years, have touted their high current capacity and also high bandwidth. You can see their frequency response is 1 hertz to 170 kilohertz. That's really good. So the specs look good, and I can tell you this amp sounds really, really good. It is fully discrete. The signal path, there's all transistors, and it's all bipolar junction BJT transistors. And so I need to open this up. First of all, I want to bring it up on a Variac, and then open it up and test a few voltages and adjust the idle current. It's a class AB, and I pulled the manual, the service manual on this that describes how to adjust the idle current, and just check a few things out. There's Jasper, and then I'm going to install it over here. Currently, for my drum set, I don't have much of a set right now. It's kind of broken down into pieces, but I'm using this really cheap receiver. You can see that really cheap receiver down there, Insignia from Best Buy, and it doesn't really do the job. So I think I'm going to use that Harman Kardon right there, if it works. And there's my Fostix full range kits and the Gemtune Class A 300B that I'm currently not using turntable. I had recently renovated my workshop here. I probably have a video of this already, but this is an all new workshop. This whole side is my electronics side. That computer back there is not hooked up yet. It's an old computer that wasn't being used, so I figured why not tap into the network and at least have access to internet down here. And some storage down there. These speakers, those speakers are connected to those little binding posts right there for testing. Those are my cheap speakers that if something happens to them, an amplifier blows them up or something, I'm not worried about them. So this whole side is electronics, and this other side is all workshop for working around the house, mechanical stuff. Okay, so I'm finished. So this is all new. Just last night I installed a separate second light. I had a little light issue over here, so I had that light up, and last night I installed that one. And now I don't have any shadow areas over here. That's a good thing. So anyway, before I get started on that amp, I'm going to put some larger speaker wire on my dummy loads. What are these things? 100 watt, 8 ohm, 100 watt wire wounds. And then I need to create some, I don't know what you call those things, but those, I used to have the shorting caps. You know, when you're looking at looking for noise in a circuit, you want to short out the inputs and just start tapping off various points in the circuit, looking for sources of noise, looking for other issues. So when you don't want a signal input and you don't want your amplifier amplifying any errant signals in the air, you short out the inputs. And I used to have these little caps you push into the RCA inputs to short them. And I lost those in the renovation, so I want to create a couple of them out of this just by snipping these off and soldering the ends together. I'll do that first, and then I'm going to take a look at that Harman Kardon. And as usual, it's late at night. Oh, another interesting thing. It was just maybe see something here. It's just maybe 2 weeks ago that they had the announcement that that Radio Shack was about to close. And I was looking through all my old electronics manuals and books and things like that, and came across the very last Radio Shack catalog. I remember the day that I picked this up. I remember the day that I went in the store and got this thing, because I remember the next year I went and looked for the catalog, and that's when they said, oh, no more catalogs. So this was the very last Radio Shack catalog ever. And what year was this? 2002. 2002 Radio Shack catalog. And I've kept it just because it was the last one. I used to love, when I was a kid, back in the what I think are almost the glory days of hi-fi and audio and stereo, back in the late 70s, early 80s. It was just awesome back then. I used to look so forward to the new Radio Shack catalog. You know, to me, when you're a kid, you don't know. I mean, you're not jaded by anything. You just know what you like, and you know, even though it was inexpensive, cheap stuff, and they're, you know, I'm sure that real hams and all, you know, had better sources. Hams liked Heathkit, things like that, but all the stuff at Radio Shack. The Radio Shack was just a great place to go. You know, they had stereos and speakers and parts and components, and for a kid who liked electronics, it was just it was the best. And I used to look so forward to the catalogs coming out, and I think it's a damn shame. It's a damn shame that they're going out of business, but that's just the way it is. They only stayed in business, I understand. Well, they were kind of struggling in the early 80s and mid 80s, and then they started selling computers, personal computers, and they made a kind of big comeback as the days of them selling audio equipment was kind of fading away. The PC business was taking off, and they had the TRS-80, which I had one, by the way, and that kind of kept them in business for a while. And then, of course, the last 10 years or so, they've been trying their hand at cell phones, mobile devices, and that's not working out so well. There's nothing left, so there's really no stores left to kind of go down to buy a capacitor or something. Not that they had much of a selection, but they had something. So it's kind of sad. And here's one to look up for those of you who don't remember. There was even a better store than Radio Shack that was real similar to Radio Shack. It was called Lafayette. It's a New York-based company, and Lafayette was like a direct competitor to Radio Shack. They had, they sold parts, components. They also sold records. Not a huge selection, but some. And they had their own brand of stereo equipment, just like Radio Shack had their own brand of speakers, and Optimist and Realistic and all that, several other brands. Lafayette had their own brand of audio equipment. I'm sure it was made by somebody like Panasonic or something like that. But and my first halfway decent system was a Lafayette system, because they went out of business back in, I'm guessing, I don't know exactly when. I was not even a teenager. I don't know how old I was, 10, 9 years old. So I think they went out of business in the late 70s, 79, something like that. I could be wrong. I haven't looked it up, but it was around there. And they had a going out of business sale, kind of like what Radio Shack is doing now. And everything was, really reduced. And their top of the line receiver, which is in their catalog. That's another catalog I used to look forward to getting, the Lafayette. Their top of the line receiver, this big, kind of like those big Pioneer receivers of the 70s. If you remember those things, the glory days of the receiver with the dial you could turn and watch the tuning dial. It was on a flywheel, go from one side to the other, and that was like kicking the tires of the car. Anyway, the biggest receiver, I'll never forget, it was LR120 dB. Lafayette radio, 120 watts per channel. dB stood for Dolby. They had Dolby noise reduction circuit built into the FM side. Somehow it worked with FM. Not even sure how that worked, but so that receiver back in the and this is going to be surprising, but if I remember right, that was like an $800 receiver back in '79. Huge. Thing was colossal. And my dad and I were watching that going out of business sale, and they finally reduced it, the last remaining ones, down to like $150. So I ended up getting one, an LR120 dB. By today's standards, the circuitry wasn't all that great in it, but just the looks of the thing and the size of it, and it's like driving around like in one of those old Mercedes, old diesel, just built like a tank, just awesome. I love that thing. And so that was my first real electronics. I say real, before that we went to, mom and dad my stereo came from Kmart. It was one of those Lloyd's all-in-one record player, AM FM 8-track thing, and it was a piece of crap. Speakers were 5-inch full range, little tiny magnets, nothing. Sounded like crap. So Radio Shack, Lafayette went out of business. Then now Radio Shack, and so now it's basically it's all catalog stores, and there's a lot of good companies out there, but there's just something, just like the death of the record store, it's just one of those little pleasures in life that you just don't get anymore. Actually going into it. Going into a store and looking around. Just checking on the dog. Yeah, actually going into a store with electronics components, and soldering irons, and stereos, and test equipment, and just actually going in there and looking around and touching things and seeing things, and the smell of new equipment, all that stuff. I say just like record stores, that was a real experience back in the day that I really missed. Everything's so impersonal now, but that's just the way it is. It's kind of sad, and I'm hoping maybe It'll make a comeback one day, but I doubt it. You never know. Never say never, but I miss those days. Anyway, I'm just waxing about this stuff. I don't know. I'm going to go ahead and hit pause and finish my soldering here, and then we'll open up the cover of that Harman Kardon and make sure it works, and maybe test a few voltages on it. Just check things out, and I'm really hoping I'm not, I don't like working on transistor equipment that much. I'm more of a tube person, but really fixing anything is fun. So I don't mind so much. And again, I don't even think I have to fix that thing. I think it's fine. Probably the worst that might happen is I might have to order some new caps. Order some new power supply caps, maybe. Or maybe not. Alright, let me hit pause and... Oh, by the way, I'm over here, right behind the camera here is my catalog. I mean, not my catalog, my reference manuals and books. And I was digging through some of my books in boxes the other day. Still got a bunch of them in boxes from my high school and college days, and came across this one. Let's see if it comes on the camera here. The Science of High Fidelity. And this was a class that I took in college. And this was back in the late 80s. And even by late 80s standards, this was an old book. Let's see if I can find a copyright 1977, 1981. So this was, outdated when I took this class. It was actually for a physics credit. A credit in physics. And I thought this was the coolest class. I mean, and this book, I bring this up because this is a really good book. It still is. It's fun to read. It's got great pictures in it. Pictures are always cool. And it explains certain things in a way that you just don't find explained, anymore. The internet's such a crappy place sometimes to get information. You think it would be the best, but it's not. Sometimes textbooks, most of the times textbooks are some of the best, and they're not all on the internet. Wikipedia is the worst. It's so impersonal and cold and missing information, and it's not explained very well, at least to the layman, the layperson. But that old Marantz receiver. But it talks about, you can see as I'm flipping through here, it talks about, it describes everything you can think of. Some of my notes here. Stuff, that's my writing. Avoiding problems, or hang mic high in the room away from reflecting surfaces, or pad the tabletop. Talking about microphones and reflected versus direct sound. So if you can find this book, I'd recommend it. It's even just a good tabletop book, just to lay around or just pick it up every now and then and read a chapter. Tuners, so it kind of covers things from the perspective of physics, but a real basic, very, very few equations kind of physics. Good stuff. I enjoyed that class. And I was an engineering student back in the day. Electrical engineering. Here I go rambling on. I was going to turn the camera off. And I got into electrical engineering. Before that I was a bicycle mechanic, but I got into it just because I really enjoyed audio. I wanted to know how to design speakers and amplifiers and things like that. Crossover networks for speakers. And I just wanted to know how it's done so that I could, do it myself. And so I was kind of thinking, I don't really want a career in engineering. I just want to know how to do this stuff. And so sure, I specialized in, as I took classes in college, I specialized in audio. Although it's funny, my real interest was, interestingly, was structural engineering. I'm not really fascinated by structures. And that is more, that's more civil engineering. And so that's kind of a fun hobby. But that, again, that's more civil engineering, and I took some classes in that more than I had to, statics and dynamics and structures and strengths of materials, and strengths of materials is really, really super interesting, actually. But anyway, I'm on a tangent. Need more solder. But so I graduated with a couple of degrees in electrical engineering, and then never been that good at soldering now. I'll admit that. So again, I've learned how to solder in high school, and I was probably taught incorrectly and all that, but I'm just sticking with what I know because I've been able to get things done. Haven't had many cold solder joints, but I don't claim to really know what I'm doing in that regard. I just do it. So I designed a couple of amps, and mostly tube amps, and built them, and then kind of got tired of it. Got a job as a night vision engineer. I say night vision because we designed night vision, maintained night vision stuff, and designed stuff, and it was fun. Without getting into details, it was a defense type job. That's where most of the night vision is used, and kind of got away from. I usually have a fan. I have a little fan to blow this fumes away from me. So I kind of got away from the audio thing for many, many years. And yeah, that's a better joint than the first one. And it wasn't until recently, like a year or two ago, that I kind of got into it again. And I remembered all the things that I ended up not liking about it too much, and that was kind of like, how do I put it? Like, it was, when I was doing design, I would get frustrated as hell. Very frustrated. And with making things work and figuring, I don't know, it wasn't, it's hard to describe, but it was the process was annoying to me, and so when I picked up again doing this, I figured, what I want to do, I don't want to design anything really. I want to fix things. I want to, buy old things, get them working, brush them off, listen to them, get enjoyment out of, a little bit of repair work and a little bit of listening, and and that sort of thing. And so that's what I'm doing now. I'm not really into designing anymore. But when you fix things, of course, and you do repair work, there's a certain amount of understanding you have to have about the circuits that you're repairing or looking at. So sometimes you got to kind of go through the schematics and figure things out, what things you're doing, what they should be doing, and why they're doing them. And just the basic rudiments of an amplifier. And so that's what I'm going to be doing with this Harman Kardon is just kind of stepping through the circuit, and I'm mostly interested in the power, making sure there's a nice clean power supply and I'm getting a nice clean signal out of it. But I'll pull the schematic and we'll look at a couple of aspects of the. It's a transistor. I say that with disdain, transistors, but it's a very good amplifier, but it's a transistorized circuit, so it's going to be one of those. But it's a very standard circuit, and I'll show you on paper. There's nothing unusual about it. If you look, when you see the schematic, it's going to look like just about every schematic you've ever seen. If you're familiar with schematic diagrams for Class AB amplifiers from 1970 on, in the heyday of the big receivers, and even that Lafayette, that LR120DB I was talking about, same, basically the same variants of the same circuit. They almost all start out with the input signal going to a differential amplifier, and then from there you go into a Class A common emitter type voltage amplifier, and then that feeds complementary output transistors in a push-pull arrangement. Sometimes with a Darlington pair, it's two of them together for, if I remember, it's called a beta or something. Beta was the gain, but the Darlington pairs the current gain is, you multiply, if you have two transistors in a Darlington pair, you multiply the betas together, so you get kind of square the gain, the current gain, that is. And there are some other advantages to it, and there's a couple of disadvantages, but they all look the same. And then there's sometimes there's some protection circuitry in there, and then there's the biasing circuitry. So, and that's kind of right between all of those complementary output transistors. So, input to a diff amp, into a driver, Class A, into the push-pull output stage, and then there's a feedback. And that's it. And they all look the same, really. So, might want to put a signal in there and step through it and see what's going on. But again, mostly I'm interested in the thing being able to turn on and produce a signal without any crackling. I'm mostly interested in making sure water didn't do damage to it, and making sure that those caps, power supply capacitors, are good. And that's the biggest concern, given that this amp, like I said earlier, was sitting around for years and not getting use. And electrolytics, I've heard they don't have a long lifespan compared to other components. I've heard people say 20 years, 15 years, some people say 10 years, but they don't, the electrolyte, I guess that's what you call it. There's a fluid inside, and the electrolytic capacitors will leak, or the fluid will dry up, in which case the plates could arc, and create a series resistance, or just a flat out short circuit, which is that'll blow a fuse immediately if there is one. But one of the main signs of a capacitor that's not quite totally blown but is leaky is a lot of static, a lot of popping and buzzing because it's not able to filter out the 120 hertz or 60 hertz noise. So we'll get to that. And I have no idea why I'm just rambling on here. Haven't made a video in a while, maybe that's it. But yeah, just rambling about nothing. When I should be, I'm almost done here. I could just about ready to get that Harman Kardon over here. Take a look at it. I don't know why. I think I make these videos I mean, I don't get many views on these things. But some of them are kind of fun, especially the videos I make about the house and the dog and the chickens and maybe some of this stuff here on electronics. Maybe the drums. I haven't played drums in a long time. I need to get back to that. But I think years later it's kind of fun going back and watching them. Kind of like looking at a photo album. But I thought I'd make a video on this Harman Kardon that I've yet to have gotten to yet. Okay. This isn't even my regular soldering iron. This is sort of my high power. Shouldn't even be using this for this application. Okay, I need to put some shrink wrap on here. Alright, this time I'll hit pause for real and come back when I'm ready to start looking at the Harman Kardon. So I just finished up my little shorting caps, I guess you call them. I don't know what you call them. You know, to stick them into the inputs, to short them out, to take measurements for noise and that sort of thing. Made 4 of them. So, I'm dropping stuff. So anyway, I'm about to get the Harman Kardon over here, but I was saying, so my first job was in night vision, and ended up not liking that too much. Ended up not liking design, really, so much. Just wasn't that fun. So I ended up moving over into the intellectual property field, the legal field of intellectual property law, let's say, like U.S. patents. Try to put stuff away here, and that's what I've been doing ever since. So I'm not really doing design for a living, thank goodness. Just didn't enjoy it. And so whenever I feel the need to actually get my hands dirty on which I still love, electronics, and then that's why I built this workshop, to come down here and tinker around. I don't think I'm really that good at any one thing. My college days were way behind me. I've forgotten a lot of the things that I learned about design. Of course, this was back in the day when we didn't have computer simulation was just sort of in its infancy back in the late 80s, early 90s. So we did most design by hand, so to speak. By number crunching and manual calculations. I guess that's what I mean by hand. And just took the screws out here. And so I've forgotten a lot of that stuff, but I still remember enough to be able to pull apart a circuit and kind of understand what's going on, and able to fix it, or at least try to. That's the fun. I don't care whether I can. It's just the process of trying to fix something. That's enjoyable, and if you get it fixed, well, then that's a huge bonus. So here's the amp. Okay. Take this off. And let me get a pointer. So like I say, there are 4 channels in here. This thing has not been plugged in, so I'm not worried about the capacitors retaining any charge right now. I'm gonna use a metal pointer, which I shouldn't be doing, but it's what I picked up just now. Really need a wood one. But anyway, I really should be using. You know what I should be using for a pointer is my. See, this is a whole new setup here. I don't know where all my stuff is. Here it is. I lost a lot of things in the renovation, but this is my capacitor discharge probe. So I might as well point with that, because I can't do any damage with this thing. I will ground it to the chassis. Okay, got it grounded to the chassis, and now I can use this as a pointer. Excuse me. You know what? This thing, as soon as I brought this over, I started getting allergies because of the dust. Look, I don't know if you can see, but look at the dust. I mean, it's a lot of it. And this is, I did a sort of a rough vacuuming of this too, with a little tiny vacuum. And it couldn't get this dust off because it's really kind of stuck to it pretty good, but now I'm getting allergies. But anyway, so there's the power, socket, and we come in, and this is not, you can kind of see things without even looking at a schematic, what's going on. There's our fuse, our fuse, and then which the hot side should be fused to black wire, or the hot wire. That is a 8 amp slow blow fuse. Always want a slow blow for the input. And then here's our primary side. There's another, something else taps off and goes up front. Oh, I'm sorry. This right here goes up to the power switch. So power switch through the fuse into the switch, back out of the switch, over to the primary side of the transformer. So 120 volts goes in, and then you have the secondary side that this transformer's got a bunch of wires coming out, so it's got a bunch of taps. Probably what happens is various circuits in here need different voltages to operate. I see there's an integrated circuit right there. There's a couple of them in here. These are some, I don't know what they are, op amps. Some of them might be 555 timers and things like that. And so they're going to need, 12 volts or 15 or whatever they need, and they're going to need to be regulated too. And so you're going to have various taps off the primary side, and then some of them are going to go to voltage regulators, and then the highest voltages are going to go right into the power supply, which includes the 2 largest electrolytic caps, and that's going to be the power supply to the output stage. The current amplifier, which is the Darlington pairs of the output, the part of the amp that needs to source the most current. It's basically the output transistors. So we come over, you know, here's our output trend. This right here, by the way, I better look before I speak. Yeah, it's a 4 terminal guy. That is a bridge rectifier. So we come in, hit the bridge rectifier, full wave rectifier, then into our capacitors, and I'm sure these go right over. This, no doubt, is the output board. You can see, I said earlier, there are 4 channels. Sorry for the shaky camera, I'm trying to hold it and do this. There are 4 discrete channels, and you can kind of tell from the circuitry that there's looks like 4 identical circuits. So each output amplifier comprises about 1/4 of the board, and then let's look down into the heatsink and see how many transistors there are, or at least how many large output transistors there are. 1, 2, 3, 4, 5, 8 of them. So each channel, those are 3 prongs. So the 2 final transistors are the ones sinking the most current, and those are the ones hooked to the heat sink. And this little guy, I don't know if you can see this or not, this little guy right here is a thermal protection circuit, no doubt. It's affixed right to the heat sink, and I'm sure that just detects overheating in situations where this amplifier is not well ventilated, and like when people stack things on top of it, which you should never do, because you know, this amplifier needs to breathe. It's just standard convection that causes the cooling here. There's no fan in here. There's no forced air. So we've got that circuit. I'm just thinking out loud. All right, so what I want to do is, the first step here is to hook up a dummy load, the one that I just completed, or just fixed. To hook up a dummy load, because one should never turn on equipment without a load. Although I am dead sure that this amplifier is well protected. And let's see. And I just want to I want to bring this up on a variac. And to make sure it lights up and nothing, you know, there's nothing fries. And that's the first thing, you know, before I even put a scope on it. Okay. I have my variac. Get rid of the soldering iron. The variac is plugged into the isolation transformer, because this particular variac does not also serve as an isolation transformer. So variac to isolation, isolation to power strip. And here is the power cord for the, or I don't have the actual cord, this is another one, but it's the same style. I'm going to go ahead and plug it into the amplifier. I'm going to turn the switch. This has a switch on the front panel. We'll turn the switch on, and I'm going to turn the voltage on the variac all the way down. I'm going to turn it on, And another thing that I'd like to do, even though the Variac has a little meter on the front, I don't know how accurate it is, and I would really like to know. Let me turn this off. I'd really like to know the AC voltage. So I'm going to hook up some alligator guys on the inside directly across the hot I got too much stuff here. This is a safety hazard. Directly across the mains, the hot and the neutral, so I can get a real-time idea of the actual power that I'm supplying to it. Got to be careful because these things are going to be hot right there. Okay. AC voltage on. Let's go. Power switch. I'm not going to touch anything. Okay, you can see right now we're at about 31 volts. $45. Okay, did you hear that? Those were, listen, I'm going to go back down. Okay, those were relays. We go back up somewhere around 60 volts, the relays kicked in. Yeah, 80 volts there, they kicked in. Those are relays. I don't know where they are. I mean, I think they're probably relays that connect the speaker loads to the amplifier. Not sure where. So far so good. I'm 109, 110. Let's go to full 120. And there's nothing smoking. The front, I can go around the front, make sure the LEDs are lit, and they are. I don't hear anything. I don't smell anything. I don't see anything. So this amplifier is powered up without a signal. And I'm just listening. It seems to be working. So that's a good sign. I'd like to go ahead and just put a signal through it. I think I'll do that tomorrow night. I think I'm done for tonight because I'm getting tired. I always end up doing these videos late at night. It's a Sunday night tonight and it's late. Like I always sometimes I end up doing these videos at 2, 3 in the morning after my work. Alright, turn this thing off. Switch off. And I like to unplug. I'll leave the isolation transformer plugged in because I'll be needing it. Now I'm unplugging. I always like to unplug the isolation transformer. There's no better isolation than that. Okay, so that's good. It actually turned on, and it wasn't. Again, that's the first thing: the smells, noises. So what I'll do tomorrow night is start testing some voltages at the speaker, making sure there's no DC on the output, and I'll pull out the schematic and we'll look at the circuit and measure a few things. Mostly power supply voltages, and make sure everything's in order, and then give it a listen. And I just want to see how noisy those caps are to see if I need to replace them, but I don't know. Wish I knew how old they were. There's no way of knowing. Tell you what, they'd be a pain in the ass to replace. They glued them down. Alright, enough's enough for tonight. I really spent a lot of time talking about a whole lot of nothing, but it's been a while since I made a video, and it's kind of fun, I guess. So, like I say, part 2, I'll start taking some measurements. Till then, good night.